In this presentation, we're going to talk about functions and data passing. And I'll go ahead and tell you, if you're new to programming, this is one of the places that students typically get hung up a little bit because there's a lot that's going on. And so to help overcome that, I've tried to visualize what's going on internally in the computer's memory. So as an overview, we'll talk about terminology, depending on the kind of textbook that you're working in. We'll talk about why we have functions. We'll talk about data passing, something that I call the mantra. We'll talk about how to call these methods, and then we'll also talk about a tricky kind of concept called the scope of variables. So first of all, you need to be comfortable with the terminology that you're working with. And when we talk about a function, it's just a logical grouping of statements. By that, we mean that these are reusable chunks of code so that you can write them once, and then you can call them as many times as you want. There are numerous benefits to this. First of all, they're reusable, they're easier to work with at a higher level of abstraction. And the reason is because we can tuck away those details in these chunks of code and not worry about that. So it reduces the complexity of our code, and technically it reduces the size of our code as well. So depending on the kind of textbook and language that you're working in, functions can be called a couple of different things. Here are some examples that we're talking about. It could be called a procedure, a module. When we move into object-oriented programming, it could be called a method or a behavior, or even a member function. So why do we have functions? Well, if you were to look at this code, you could see that there's a lot of redundancy in it. So I've highlighted that redundancy here, and you can see that all of this code highlighted in red is the same code. So instead of having 3 individual copies of this, what I can do is create a function instead, and you can see I've moved that code over here into this blue rectangle, and then you can give it a name. In this case, we'll just call it some arbitrary name like my function. And then instead of having all of these copies over here on the left-hand side, we can just call my function instead. So these functions over here on the right-hand side actually have a name, and you can use that name instead of having to rewrite that code over and over again. So what have we done? We've written this code once, but we've called it several times from our main code. If you notice, this also reduced the size of our code because we've eliminated all of that redundancy that was there. It makes it easier to understand, and it also introduces something called procedural abstraction, meaning that we've pushed a lot of the details away from our main code and packed them into these functions somewhere else in the code. Okay? Also, the tracing of the code is going to skip around. It's no longer going to go from the top where we had main down to the bottom of the code. Now it's actually going to skip around as we start to trace through it. Okay, the next thing that we have to talk about is the scope of variables, and by scope it means who can see what and where they can see it. Variables that are defined within a function can only be seen inside that function, and this is a hard concept for people to understand too. So we need a way to be able to send information to the function and also to get information back from the function as it's running. So let's see an example of what we're talking about. Imagine that I've created this function called function1, and then I've got another function called function2. Inside function1, I have a character, you can see it right here, called mychar, and then here in function2, I've got another variable of type int called myint. Now realize that function2 cannot see mychar over here in function1, and then conversely, function1 can't see myint. And the reason is because we defined these variables inside that function. So going back to this mantra, if you're ever asked to write a function or a member function or whatever it is, they always follow this pattern. And so it's always going to be the return type, the function name, and then any parameters that you need to pass to that function for it to do its job. And so you can say this several times over and over again to kind of drill it in your head because it follows this template. Okay, so when we're talking about the return type, a function has the option to return back to main some kind of information. This could be a number, or it could be a string, or it could be some complex data type, who knows. Okay? If the function doesn't return us any information, the return type is going to be void, meaning that it's returning nothing. It still returns something, but it's returning nothing, if that makes sense. Otherwise, the return type is the data type that it's going to return. And so examples of return types could be something like an int or a char or a boolean or a string or any number of things. But those are the valid return types. Okay, so here's some examples of that. If we had an average function, we can imagine that its return type might be something like a double or a float. Notice that it's not returning us an int because chances are if we're averaging things, we're going to get back some arbitrary number that's like a decimal point. Okay? Get letter grade might return us a char, A, B, C, D, or F. Are you asleep? If that was a function that we had, it would return us a boolean. Get GPA might return us a double or a float. And again, notice that it's not returning us an int. And then this one's always confused students here, print menu. So if we wanted to write a function that would print a menu to the screen, notice that the return type is void. And you may have thought that it would return us a string. But don't confuse what a function does with its return type. For example, if I told you to go up and write your name on the board in front of the class, notice that you're not returning me information, you're doing something. You're writing on the board and you are writing a string there, but you're not returning me that information. Okay, as a final example down here, get student name might return us a string. I think that one is fairly straightforward. Now, with regard to the function's name, they can be just about anything you want. It's a very similar naming convention to variables. First of all, it can't be a keyword or a reserved word. It can't begin with a number. It can't contain any of those strange symbols that we've seen except for the underscore and the dollar sign. But there is a convention that Java programmers use. Typically, function names should begin with a lowercase. And then if you have multiple words in that function name, you typically capitalize the first letter in each successive word. So what do we mean by that? If I were to create a function, I might use this as the function name. This is an example. Notice that we start with a lowercase letter here, a T, and then every word that's in that function name begins with a capital letter. And that's just what Java programmers use. You don't have to do it, but that's kind of the accepted standard that programmers use in Java. All right, let's look at parameters. Parameters are the way that we get information to the function. So if you go back a couple of slides and remember that we talked about scope, functions can't see each other's variables, and that includes main. Believe it or not, main is a function. So these parameters are special variables that are used to catch data that's being passed to the function. And don't worry, we're going to visualize this in just a second. This is the only way that the main algorithm and the functions have to communicate. Parameters, or these special variables, are going to be located between parentheses. And if no parameters are needed, then you can leave the parentheses empty. All right, so let's see an example of this. And we're actually going to visualize how things work in just a second. But if you go back and remember the mantra, you can tell me a couple of things about these functions below. So what would you say about do something? Well, you could see that it's not going to return us any information, right? So I'm not expecting anything back from do something. But I do have to pass it an int for it to do its job. So when I call do something, I better pass it something like a 7 or a 14 or whatever it is that you want for do something to do its job. Another example would be average. Notice that I'm passing it two numbers that are integers, num1 and num2, and it's going to return me back a double. So I better be prepared to do something with the information that it is returning me. Did he pass is another function here. It's going to return me a boolean, and I don't have to pass it anything. What was his grade is going to return me a char, and again, I don't have to pass anything. And then scare student is going to expect a name of a student, and it's not going to return any information. So it's almost like we have a contract. If I call this function, I have to either pass it something or not pass it something, but it has to match what it's expecting. And then if it does return me information like you see right here, I better do something with it. Okay, so how do we get this function to work for us? Well, first of all, you just call it by its name. So if we went back up here real quick, you could see do something, average, did he pass? I have to use that to call that function and get to work for me. Second, I have to pass it the right stuff. By this we mean the parameters. So I have to pass the right number of parameters. In other words, if it expects two things, I better pass it two things. It also has to be the right type of parameters. So if it expects a character, I can't pass it a double. In other words, parameters have to match exactly. Also, if it's going to return us something, you have to do something with the result that it's returning. You can either store it in a variable, or you can print it out to the screen or write it to a database, something. Here's probably something that you should really pay attention to, because this visualizes exactly what's going on. Notice that we have here on the left-hand side, we have public static void main. So here's our entry point, right? We also have a function that exists out here somewhere. Now, this could be in the same file, or it could be on a whole nother computer. You don't know. You just know that you have access to it from main, and you're going to see the function call here in just a second. Now, what's going to go on when we trace through this code, we're going to start here at main, And let's go ahead and go to line 1 right here. So we say int num1, num2, num3. So what's going to happen? We're going to open up 3 chunks of memory, num1, num2, num3, and we have no idea what's on the inside, even though technically Java initializes those things to 0. A little bit later on, we have double result1, result2, and you can see the same thing happens. Result1, result2 are here in memory, and we don't know what's on the inside. Next line down, we initialize these 3 variables to starting values. So I put a 5, 7, and 4 inside of these variables. And this is where it gets a little bit more interesting. So this is where we're calling the function. And how do I know that I'm calling a function? Well, you can see it right here. You see I'm calling it by its name, average. And this is the part that I wanted you to pay particular attention to. Notice that we have access to 5 different kinds of variables here, num1, num2, num3, and result1 and result2. Now I'm calling this function, passing it num1 and num2, but if you look over here, you don't see anything with regard to num1 and num2, it's x and y. So what's going on here? When I call this function, notice that it wants 2 things. It wants 2 ints, right? Int x and int y. So what I do is I pass num1 and num2, but I'm really passing copies. So num1 comes over here, and its value gets put into x. Num2, its value gets put here into y. So I've copied the values of num1 and num2, which are 5 and 7, and put them here into x and y. And you may be saying, well, why don't I have variables here, num1 and num2? That's not the way that it works. When I have it as x and y, that means that I can pass anything over here, and I can reuse this function regardless of what the variable names are called over here. So again, just to kind of summarize what I said, the 5 from num1 gets copied into x. The 7 from num2 gets copied here into y. Then what happens? Well, main falls asleep. Main is no longer active at all, and this function is now running. So what's it going to do? Well, x is initial value of 5. Y has an initial value of 7. So we can go in here and we can say, fine, x plus y, that's 5 plus 7 is 12, divided by 2 gives us a 6. So the question is, where does this 6 go? Notice that it says return a 6. Okay, so where does this result go? It's going to go back here into result 1. So you need to look at it as a two-way street, right? Our parameters here go into the function right here into x and y, and then we return something back, and that goes back here to main, and then in this case, we're going to put it into this variable result 1. Okay, so the end result, after everything's said and done, we're going to put a 6 into result 1. And I know what you're saying, hey, we could have just averaged these numbers here and shoved the result into result 1, but typically these functions have a lot more code in them. So let's see another example then. Coming down here, notice that we're reusing this function, average. This case, though, I'm passing it num3 and num1. So what do you suspect is going to happen? Well, num3 has the value 4, and num1 has the value 5. So in this case, taking the value 4, copying it here into x, taking the value 5, copying it here into y. And again, the same thing is going to happen. Now main is going to fall asleep, and this function is the one that's running. It's awake, and so it's going to return us the average of these two numbers. So it's going to return us 4 plus 5 divided by 2, which gives us 4.5. Now again, it says return, so where does that go? It's going to go back here into result 2, and then you can see that we're going to update our memory chunk right here to get the value 4.5. So if you can understand that, that's really important because it shows two different things. It shows us passing information to the function, and then it also shows how that function returns information back to us in main. As one final example here, you can see that we've changed things up just a little bit. Going down here and looking at the function, it's called PrintNum. It's really kind of arbitrary. It's not a very powerful function, but it does take in a parameter, and notice that it returns nothing in this case. So how are we going to handle this? Well, we'll walk through this one again. We have num1, num2, num3. So we open up 3 chunks of memory, and then we initialize those things to 5, 7, and 4, just like we did last time. Now, notice that we're about to call the function. So when we do that, it wants us to pass it an integer that it's going to call mynum. And so in this case, we'll take num1, take its value, copy it here into mynum, and then main is going to fall asleep again. So the same thing is going to happen here. In this case, we just print out the number to the screen, so a 5 is going to pop up here on the output or the console, depending on what it is that you're using. And notice that there's no return statement in here to come back here into main. Whereas before, notice that when we said return, you had to have a non-void return type in your function. Okay, so the function is now done, and then the function falls asleep, and then we return back here to main. So in summary, the function rules, first of all, you can't define a function inside of another function. It's just not allowed. So going back up here, looking at this one, we can't have another function on the inside between the beginning of the function here, this opening curly, and the closing curly. It's just not allowed. If you're going to write another function, it needs to occur after that closing curly. Okay? Functions are going to usually reside inside of a class, and that's actually what we'll be talking about next. If you want to put the function in the same class as the driver, just to practice and such, you have to make it static, and I'll give you a tutorial on this one as well. And then finally, remember that functions can't see each other's variables. So if you define a variable inside of main, only main can see it. And if you define a variable inside of a function, only that function can see it. And to get the information from main to the function, we're going to have to use parameters. So here's an example real quick if you want to see a static function. Here's one right here. Notice that we're inside of the main driver right here, public static void main. And if I want to create a function just to practice here, I kind of break some rules, but I can append this word static here before the function, static void PrintNum, and then I'm allowed to call it here from main. So that's it for now. Hopefully that helps a bit with data passing and how to declare functions.